Welcome everybody to another cosmology segment. It is an incredible time to be doing stuff like cosmology because we've got various aspects of cosmology, astrophysics, and geophysics in the process of being rewritten. Don't believe me? Well, let's get into the video. Some of us consider heliophysics cosmology, and there's a distinct reason for that. The reason is because heliophysics is sort of under the guidelines of the standard concordance model of stellar evolution. The standard concordance model of stellar evolution is some really ancient ideas, and it involves a fusion core dynamo inside of gaseous stars, and it involves the surface of these stars having a simulated surface instead of a real surface. In other words, the reason that this looks like a real surface, according to the standard concordance model of stellar evolution, the reason that looks like a real surface is because of a combination of gas pressure and gravity. So gas pressure coming from the inside, from this nuclear fusion core dynamo, and the output from that as hydrogen fuses to become helium and releases all kinds of radiation and neutrons and so on. And so that's a little bit about why heliophysics is cosmology. Let me refer you to something you may have never heard of before. It's kind of important. And you can find links below this video to smAsho.com/forum. You can also find a link on the homepage. And on our forum, smAsho.com/forum, we've got a cosmology forum. So feel free to go peruse the subjects over there. One of the subjects is well, there are a lot of subjects there. Let's just put it that way. And so without going any more in depth into what's there in the cosmology forum, we've got a forum specifically about heliophysics. So if you head back to the main page and you scroll down, you'll find the sun. Now there's a solar events logger in there and so on. A lot of this stuff is not as updated as it will be soon, but we've pinned this one, the liquid metallic hydrogen solar model. So in many people's opinion, this is the most important science paper of our lifetimes. We've got a link to it, and we also included the entire paper here. 40 lines of evidence for condensed matter, the sun on trial, liquid metallic hydrogen as a solar building block by Pierre-Marie Robitaille. And if you search for the YouTube channel, you'll find Pierre-Marie's YouTube channel known as Sky Scholar. So make sure you check that out. Go subscribe to his channel. And you'd be well advised to watch the videos in order. So if you sort them by the oldest, start out with History of the Gaseous Sun with Dr. Robitaille. It's quite spectacular, and so is this paper. So make sure you read 40 lines of evidence for condensed matter, the sun on trial, liquid metallic hydrogen as a solar building block by Pierre-Marie Robitaille. It's quite spectacular, and we've got all kinds of other links here on the page as well. So a ton of links here about all of the other aspects of the more likely explanations for why we see what we see coming out of the sun, whether we're talking about things like the emission spectra, transverse waves associated with solar flares and coronal mass ejections, and 38 other reasons why it's much more likely that stars are made of condensed matter and not gaseous plasmas. So that's pretty serious stuff, folks. And I just wanted to, again, reiterate the importance of this. Please tell your friends, foes, science noobs, and science pros about this paper, as, again, in my opinion, this is the most important science paper of our lifetimes. This is Galileo scale stuff. And the plausibility of what radiographer, spectroscopist Pierre-Marie Robitaille has to say. Put it this way, folks. When it comes to spectra, when we're looking at radiation, right? Photons, only certain things can produce photons. And that's the basis for most of this reasonable and plausible explanation of what we see from the sun. And some of the takeaways to this are that stars are much more stable than standard cosmology would tend to have people believe. And it's seriously turning astrophysics and cosmology on its head. Also, I'm not a believer in the cosmic microwave background. I want to see the cosmic microwave background measured at L2, Lagrange point 2, a thing that'll never happen. I'm not going to talk about the emission spectra of water. I'll just say that water emits radiation. And it's distinctly possible that the universe as a whole doesn't, because there's an issue with the measurements of the monopole. I'll just leave it at that. Pierre Marie's a little better explaining this than I am. So let's continue on to the rest of our cosmology segment here, now that we've briefly talked about the most important science paper of our lifetimes. We've picked a random number that will associate with an object at the Neil Gehrels. So today's random number is 251, which coincides with something of 1,050 objects. Let's see what 251 comes out to be. It is a quasar. So this is a special type of active galactic nucleus, one where the viewer is somewhat in proximity to the galactic jets. This one's called PKS 0742 plus 10. So here are the hard X-rays from this quasar. And again, a quasar is an active galactic nucleus that has a specific orientation. So when we're viewing a galaxy, orientation is everything, folks. If you're viewing a radio galaxy, you're going to typically see a shape like this. And that is because you're viewing the galaxy from the edge on. Now, we expect that the Milky Way is a spiral galaxy based on the features that we see on this side of the Milky Way. A lot of the features on the other side of the Milky Way we can't see at all. But when you see a galaxy in this shape, this galaxy may have jets that are coming out of the poles, maybe in some sort of an orientation like this. And I'm exaggerating the amount of taper when it comes to these jets. They're a little bit straighter than this, but as they emanate from the galactic cores, the matter is likely diffusing as it gets farther and farther away. And so if you're viewing a galaxy from this sort of a perspective, that galaxy is going to appear as an active galactic nucleus, probably something like a quasar. If you're viewing from this sort of a perspective, from right within the jet, it will probably look like a blazar. It'll look even brighter. And often these galaxies are completely obscured by dust and so on, and we can only see tiny portions of the spectra from them. Now, if you're viewing a galaxy from edge on, as we are in this drawing, you're looking at it, from the perspective that as you sit, this is more likely to be a radio galaxy, and we regularly see radio lobes from these galaxies, and they're typically associated with these galactic jets. So Cygnus A is a prime example. We have images of that on smAsho.com. Because of the radio galaxy, the nature of radio galaxies, Cygnus A. And anyway, what I'm saying is it all comes down to perspective. So let's get some perspective by looking at this particular quasar visually. Now that we've looked at the X-rays, that's the last 16 years in the upper right and the last 30 days in the lower left. So if you click on Simbad right here, you can find a link to this CDS portal, which contains a massive amount of information. And let's take a look at this quasar in a few different wavelengths. So first of all, here's the Swift-BAT, the burst alert telescope that we were actually just looking at. Those X-ray transients are a different expression of the same data here. The Swift Burst Alert Telescope, the 70-month hard X-ray survey. So you can see there's a pretty dim spot there associated with this quasar, perhaps. It's a fairly dim spot, so it's an indication that perhaps this quasar is at an extremely great distance, probably in the billions of light years if I had to guess, which I don't. Here's another exposure, the combined Swift XRT exposure. I have no idea what that means, but we get a little bit better image there in X-ray. Now switching to ultraviolet, you can see this is a much dimmer ultraviolet source. In fact, there's basically nothing but background ultraviolet radiation there to look at. Nothing really showing up on the Galix. So it's quite bright in X-ray, quite distant most likely. and quite dim in ultraviolet. Let's look at additional spectra, such as the optical spectra. So here's pan-stars. And we've got just about nothing showing up there on pan-stars as well. A tiny bright spot in optical wavelengths. And you can see all of the detail there in those other galaxies. That one looking pretty distant to me. We'll finish our visual analysis here on the 2MASS. See if anything shows up as far as heat spectra, and not so much. So it's a pretty quiet part of the universe there, folks. Almost no infrared or thermal emission spectra coming from that area. And continuing down the wavelengths, getting into even lower frequencies here. Check it out, 74 megahertz showing up here as a quite bright spot. So there's the galaxy showing up very well there in 74 megahertz. So back in the mid-90s, I didn't think radio astronomy was very interesting at all. My mind has been changed, and think people like astronomy professors back then tried to convince me that radio astronomy is interesting. I now agree. And that's not a new thing, folks. I've agreed for years. Let's see if we can find even more imagery here. And here's one more, the Chi-Pass 1.4 gigahertz radio continuum. And we'll zoom way in on this quasar. You can see the way the different portions of the survey are showing up here. So some radio loudness happening there on that probably very distant quasar. And one of the many benefits of the CDS portal is that it'll show you the photometric hot points, as you can see there, showing you which different wavelengths show up and so on, as well as all kinds of bibliographical data and so on. That one's showing up back in 1950 was the first time this one was apparently observed. It's quasar PKS 0742 plus 10. By the way, there was actually an interesting X-ray event right here. And it's actually been a little bit louder here in X-ray just in the past year or so. You can see this area right here, a little bit of additional activity there coming from that quasar. Again, PKS 0742 is number 251 on the Neil Garrels Swift Bat X-ray Observatory. Go monitor your favorite objects there yourself if you like perhaps if you're interested in Sagittarius A star, in that you think it's controlling the sun's activity because you know nothing about astrophysics. Well, there are the X-ray transients from Sagittarius A star. By the way, the sun is orbiting the galactic core. The sun's not interacting with the galactic core. If you said the sun was interacting with local stars, the local interstellar chimney, etc., I'd say congratulations, you know more about cosmology than most people. But sadly, if you're saying that the sun is being affected by some sort of a galactic current sheet, you should, I don't know, crack an astronomy book, learn the first thing about astrophysics, stuff like that. Continuing on. So we briefly showed this in today's daily space weather video. If you haven't watched our space weather videos, we do them daily, and that's why they're called daily space weather videos. We're going to show this one again because this is a pretty good one here. The astronomy picture of the day, located at apod.nasa.gov, apod.nasa.gov. You ever seen Jupiter get hit by an asteroid? Well, here's some footage of it. There you go. Jupiter getting struck by an asteroid, folks. It's pretty sweet. It's the most significant event, I believe, to strike Jupiter since Shoemaker-Levy 9. And who doesn't remember that? I think I heard this was believed to be a 100-meter asteroid. You can see how much that does to a giant planet like Jupiter. And let's talk about the universe's missing mass. So, is there missing mass in the first place, or is astrophysics simply not understood? Check this out. It's a Magnesium nebula. And what you're looking at here is, this is about the diameter of the Milky Way galaxy here. And you're looking at a galaxy and a quasar. So this quasar here, this is only used as a reference to study this galaxy. So this galaxy right here, if you look at it here, that's ionized magnesium. So there's a huge cloud of ionized magnesium surrounding this galaxy. The whole galaxy is surrounded by a giant nebula of metals. Yes. In cosmology, we consider everything more massive than helium to be a metal. And that pink area there, that's a combination of the optical and the magnesium emission spectra there. And that's why you're seeing that. And check out the shape of that. Let's zoom in. And we're just going to scroll across here to show all the different images to give you the maximum resolution that we could possibly provide here. It's a fairly small series of images. So great imagery there of the quasar, the the emission spectra of the ionized magnesium, and then this great overlay image. Just spectacular. And it looks like there may be a couple of jets associated with this also, because if you look closely here, it looks like there may be a structure here connecting some satellite galaxies to this main galactic core. It looks like a bridge of magnesium. Correct me if I'm wrong. Do you see that? Leave us a comment. Let us know. Moving right along to tidal disruption events. Are you familiar with tidal disruption events? Tidal disruption events are when the massive radio source at the core of a galaxy consumes a star. Now, this has only been observed in various little fleeting aspects, as this is sort of a one-off event to say the least. The possibility that a star could be torn to pieces, swallowed by, etc., the massive radio source, the pile of condensed matter in places like the core of galaxies. So it's very likely that these massive radio sources do dominate the area located at the cores of galaxies. And perhaps there's a lot of missing matter there that's moving so fast at relativistic speeds that we just simply can't see it. That's my best guess for where all the missing matter is. So this particular paper here that we were just showing you on phys.org is about 3xmm. So 3xmm is the massive radio galaxy galactic core, and it's quite bright in X-ray. There's a view of that. And let's see if we can find this one in some other spectral wavelengths. So here's the Pan-STARRS combined survey here. This is optical wavelength, and we'll zoom way, way in on this galactic core that seems to have had a tidal disruption event. So a very violent thing happening near the core of this galaxy, which appears to be offset a little bit there in terms of where the crosshairs are. Probably another active galactic nucleus similar to the quasar that we covered earlier in the video. Maybe this is a Seyfert 2 galaxy. I'm not really too worried about its classification. If you want to read more about it, you can just search on the CDS portal for 3xmm. Very easy to remember. 3xmm, probably originally discovered by the XMM Newton project. And you can also find this paper about this tidal disruption event. I'll just let this one scroll here. And the interloper was known as J2150. So that's the star believed to have been destroyed, torn apart, relocated. I don't know. Who knows? Maybe it teleported to a different dimension. Just kidding, folks. I'm just exaggerating here because of the state of cosmology that we're currently in. But hey, it's a great time to be studying this stuff, as there is a lot of stuff in the process of being rewritten, especially when observations don't back up theories. So let's do one more article here. And congratulations to the first all-civilian crewed space mission. So there you go. Haley Akrino, Sion Proctor, Jared Isaacman, and Chris Sombrowski are currently in space. Yes, you can find this article on phys.org's Astronomy and Space section as well. SpaceX's crew of tourists. Yes, now they're all scientists also, folks. But when I've been saying, if you've heard me saying recently that we're going all the way to space physically, I wasn't exaggerating. And we've leveraged ourselves in terms of talking about astrophysics and space weather and so on in an intentional fashion. We didn't just decide to throw our channel together. I've been studying things like cosmology and astrophysics since the early 1980s. I started first reading about cosmic rays in about 1980. I learned to read at age 3 so I wouldn't have to go to school. That didn't work out well, but I went to school anyway, and hey, it was fortunate. I'll admit it, 5-year-olds aren't the best at making their educational decisions. So that's today's cosmology segment, and we're going to extend the video just a little bit here to show some additional imagery of the closest star. Thanks for tuning in to today's cosmology segment. Congratulations on realizing our channel exists. Please tell your friends, foes, science noobs, and science pros about the channel. And we're just going to let this lovely paper here scroll. It's been around since October of 2013, so please catch up and read the paper. And please go subscribe to Sky Scholar, one of the best channels on all of YouTube. It's only got like 30,000 subscribers, I think. He doesn't need our help. We've not even reached 3,000 subscribers yet. Thanks to everybody who's pressed that subscribe button. Press subscribe, press like, tell your friends and foes about us. As we cover heliophysics on the daily in our daily space weather videos, and we do regular cosmology segments. So again, if you haven't read 40 lines, 40 proofs supporting liquid metallic hydrogen, a lot of these theories are more than plausible. And we're just super excited about the new frontiers of superionized matter physics, thermal physics, etc. Some of these represent capabilities in human technology that have not yet been achieved as well. And this is part of the reason why we've been saying things like, guess what? Electricity is going to be free in a couple of years. Yeah, in a couple of years, electricity is going to be free. Now, I've been complaining about the internal combustion engine since the late 1980s when I realized how inefficient it was compared to even just basic electric motors back then. But my problem was not having anything to do with emissions. It had to do with just basic efficiency, folks. And so, welcome to the neo-renaissance. I don't know what else to tell you. Go visit our links. Please support the channel via our links, smashamash.com. Consider joining the SMASH team, smashamash.com/SMASH team. Go visit our forum, etc. Thanks for tuning into our latest cosmology segment. Don't forget to view the rest of the videos on the playlist as well. youtube.com/smashamash/playlist. This paper has hundreds of citations in it and hundreds of bits of extra reading for you. If you're not familiar with what he's talking about, it's a lot to grasp. And believe me, it hurt my brain when I first started when I first heard the idea that the sun was made of liquid metallic hydrogen. It hurt my brain quite intensely. We hope it hurts yours also, as if it's causing your brain to hurt, it means new neural connections are forming. Anyway, time to sign off. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network, least busted, naming news.